Welcome back, aviation enthusiasts and fellow aircraft builders. I wanted to give you a quick tips and tricks update. These are just a couple of techniques I wanted to talk about for making things a little easier and some things not to do. I'll start with what not to do first. This is the central firewall stiffener. This is the channel. When you fold this up, the dotted lines here you can see. When you fold this up, this becomes where the nose gear tube rides, and then there's a locking pin for the bungee that slides through here for these holes. And this is actually made out of 40 thousandths, and there's a lot of time into this part. You've got to cut all these different radiuses here, lay out the bend lines properly, really do some filing work and detail work when you're doing this from plans, and all the holes have to be located exactly the right spot. These are 5/8 inch holes for the pin that slides through. So when you're drilling thin sheet metal by hand, one of the tools that Zenith recommends is the 3600 RPM Sioux air drill. I've got a similar Nova drill that's 3200 RPM. Drills through these thin sheets beautifully when you're drilling by hand, and the real high RPM really make a big difference on the hole turning out round. If you drill on slower speeds, with a standard twist bit, it has a tendency to kind of make a triangular shaped hole as the bit kind of wobbles its way around the hole, because the RPM is so low, the twists are getting caught on the edges and it's wobbling itself around the hole. So they recommend the high-speed drill to make that a non-issue. So and that includes when you're drilling through like 40 thousandths and things like that. However, I've discovered that it only really applies to small holes, like rivet size holes or maybe screw holes or small bolt holes. What I did today, I got my new oversized drill bits in the mail this weekend, so I got my 5/8 inch bit. I bought a whole set of oversized bits, but I got my 5/8 inch bit, I put it in the drill chuck, and I mistakenly applied the same high-speed logic to the drill press. So I cranked my drill press up to 3600 RPM, balanced them. I had to balance and adjust the motor so there wasn't any vibration on it, but it was fine. There was very little vibration. Went ahead and clamped down the work and set about drilling, and this is the hole I got. This is now wider at the widest points, so you can see where the jagged throwout areas are. That's much wider than 5/8 of an inch now, and in fact the entire hole is wider than 5/8 of an inch, so I can't use it, and you can see all the tearing and awful mess that became. So I had a pilot hole and everything, so that wasn't an issue. It just the drill press, that large bit teamed up with some extra vibration, and it just bullied its way through the metal without drilling a nice hole. So I had to back it down to 540 RPM and drilled a 5/8 inch hole with the same bit. No problem. It's a beautiful hole. I haven't deburred it, but it's a beautiful hole. Perfectly round. Exactly what I was hoping for. That was the first time I'd adjusted the drill press to drill faster. I take that back. That's the second time I've adjusted the drill press to drill faster, but I've never had it set that high. And so now this part is completely ruined, and unfortunately I have probably a good hour into this part already, if not longer, between drilling the lightning holes, laying out all these radiuses and coordinates for all the different holes, and then deburring everything so that I could get it ready to bend. All I had to do was drill that hole and that hole, and it was ready to bend, and it was done. That's the only part in 40 thousandths I had left to do, and I've already rolled up my 40 thousandths and put it away, so I've got to get it back out and remake this part and drill it on a slow speed. So for hand drilling, the tip there is, the higher speed drills, the pneumatic drills, the 3000, 3200, 3600, even 4000 RPM drills, they're great for hand drilling your rivet holes and things like that. But if you're going to get into larger diameter holes, definitely do not use a high speed drill. You want to use drill press. Aluminum typically does a little better when you do have a little higher RPM, but on these larger pieces with these big diameter holes, it just does not apply. So learn from my mistake, and if you already knew better, good for you. I mistakenly applied that logic, and now I'm going to spend another couple hours making this part probably, because I got to get out the material and start all over. But at least I can trace this and then file it back to the tolerances. So that's basically a don't do what I did example. One of the tips I want to give you is when you're working with The thicker materials like 40 thousandths and 63 thousandths, you're really going to need to have some kind of a sander. If you don't already have a belt and disc sander combination, or maybe you just have a belt sander and maybe a spindle sander, that's fine. But one of the recommendations I have when you're working with the aluminum is so soft that if you were to put it down on the sanding fence here or the platform or up against this sanding guard, it will scratch. And if you take and use like duct tape to protect it, or painter's tape or anything like that, the metal gets hot very quickly. The aluminum that you're sanding gets hot very quickly, and it heats up and it starts to melt and liquefy the glue and melt the tape and things like that. So duct tape, it just flat out melts it, turns it into just rubber cement like looking stuff, and it sticks to your part, and you've got to spend some time with acetone getting it off of there, and it just isn't good. And then so the other option is if you're using the sanding bed or the fence here to directly against the aluminum, it'll scratch it, and then you have to spend some time polishing it. So my solution was very simple. I just traced a rough piece of wood that's the exact same size as my sanding bed here or fence, and drilled a couple of small 4 small holes in just randomly in where the inside of that, and then screwed up from the bottom with some sheet metal screws, even though I'm screwing into wood, just some panhead sheet metal screws right up into that. And now I've got a good wood surface that isn't going to burn or melt or have any weird behaviors on it. I can put as long as it's clean and smooth, I can put the workpiece right on here and not have to worry about it sticking with glue or tape or melting the tape. And of course with wood, I'm not worried so much about it scratching either. I did the same thing on the little sanding stop up here. I basically use this like a fence or a platform when it's in the vertical position, although you can use the large platform here in this position if you're doing a lot of work up here. This actually, using this piece up here, makes it easier. But this belt sander combination, the Craftsman, I've had this for many years, works very well. But again, just added, I think this is maybe 1/2 inch plywood, also with just some panhead machine screws drilled through here to hold this on from below. So one little tip there, so that you really avoid scratching and then having to do a lot of extra work and cleanup on your aluminum afterwards. Okay, and one other last tip that I wanted to talk about was in my scratch building concepts and tips series, I talked about saving all your tooling when you're working on your project. So don't get rid of your form blocks, don't get rid of your holding fixtures and jigs and things like that. Keep those things till the end of the project. But that also applies to things like test pieces, or if you're using there's a couple places where you've got to make a large radius curve in some things, and so I use this thick press board with my drafting compass because it's got a lead holder. I draw these out and then cut them, and I actually, because this is slightly over 1/8 of an inch thick, I can actually sand this like it's a piece of wood on the sander. So I've got this large radius template here so that I can trace it on the workpiece, and same here, I've got a large radius here that I don't have a circle template for. This piece I made so that I can actually draw, if I anchor it in one location and then put my Sharpie through the next hole, I can actually use this as a compass to draw a big large 200 millimeter radius circle. I've showed you this before. This was my test pattern for the landing gear channel. So what you'll want to do is, you're probably never going to need these things again, but in the off chance during assembly or while you're storing a part that you've already made that you damage it, or during assembly you either damage it or you drill it, or fix it in the wrong location, you drill a hole where it shouldn't be, or you mess it up somehow, you'll still have these test parts and test pattern pieces here with the measurements, that tell you where your bend lines have to go and everything else. You'll still have these pieces so that if you have to go back and remake the part, you don't have to refigure out how to bend it. Or in this case, I don't have to make another template for a 115 millimeter radius curve or a 200 millimeter, things like that. So when we talk about tooling, it's not just things like your clamping fixtures or holding fixtures, any special tools that you make, like my solid riveting C-frame or things like that. Of course, you should keep those as well, but it also applies to things like little templates and test pattern pieces. Now, I violated my own rule and accidentally destroyed the test pattern piece that I made for my fuel tanks. If I screw up my fuel tanks when I'm welding them and I have to remake those, I'm going to have to go back to the drawing board and figure out my bend lines for the skins on those so that they fit the ribs. So, you know, if I'd have held on to that piece, then all my measurements were still on it. I could have just laid out a new skin, marked it, cut it, bent it in the right place, and it would have fit the ribs. So keep those things in mind when you're working on your projects. Keep all of these things handy, put them in a box somewhere, you know, however you want to keep it organized, and but ready to access if you do need to do it again. That's all for this video. Be sure to like, comment, or subscribe, and let me know if you have any requests for future video content. As always, thanks for watching, and good luck with your projects.